Hello everyone, welcome to AI Anytime channel. So I'm starting a new video series on graph neural network. So this is going to be a multi-video series where I'll have around 20 videos and I will cover graph neural networks or GNN from scratch. So we'll start from the fundamentals and basics of graph theory, from graph to graph neural network, and in this entire set of videos we'll cover the fundamentals. What is graph, why is it required, what are the graph theory, what are some of the algorithms that are famous, that have been used in industries across the problem statements. And we'll also look at around deep work, and then we'll use this classical machine learning algorithms, how we can use graph algorithms to solve those problems, like building a movie recommender system, or creating a social network solutions based on this social data. And then we'll also move towards graph convolutional neural networks, and we'll have a look at all these algorithms and why graph neural networks are kind of booming, and it's becoming very popular as a deep learning architecture. Okay, so this is going to be the first video of this series. And graph neural network has been very popular lately. It has been used across industries and domains. If you talk about drug discovery, it has been used to in these domain of antibiotics. There have been some famous development that has happened with graph neural networks. Then if you talk about I was talking about social network, right? So in also in mobility, Google Maps uses graph algorithms to in their maps. And Facebook has also used graph networks and graph based algorithms to basically for this relationship. They recommend, or they the friend request feature that Facebook has. This is all based on graph theory. So we are going to see how we can use this to build better, how we can use this graph based algorithms and graph neural networks mainly. Okay, I'm not going to focus more on the graph based data structure. Of course we'll cover some of the algorithms, but more focus will be towards graph neural networks. But I will cover fundamentals and basics of it in this video series. So graph theory is basically a mathematical study of graphs, and has emerged as a fundamental tool for understanding complex system, and these patterns and relationships between the features of your data that you have, right? So it's basically a visual representation of a collection of nodes that I will show you. Okay, and it's called vertices, and that connects these nodes to represent entities and their relationship. Now let me just show you that how it looks like a simple graph structure. If you see, I'm creating some kind of structure over here, and I'll just connect this right now. I'll talk about it, what these connections are basically. So this is a structure that I have created. This is one of type of graph. You see this, let me just assign some number over here. This thing that you see, these are basically called as nodes. These are called as nodes, and these things are basically called as edges. So we'll discuss about the notation, formulas, and everything, that how we calculate these edges, what are the mathematical formula and representation of these things in bit. But currently, this as a structure, these are the nodes and these are the edges. If you see, and it represents some kind of entities. Currently it's not making any sense, but it will make sense when we go further deep into these things. So we have around 6 nodes here, and we have around this edges as well. So we have 6 edges for this. Okay, so these are basically edges, and we have 6 nodes here. So Now we'll discuss that where can we use this basically this graph based neural networks or graph based algorithms. Okay, now I'll just take an example of for example this social. Okay, they have been used in different industries, social sciences for example, social sciences, physics, in biology, in a lot of other industry, finance, and I also cover finance in little bit of details, because finance graph based algorithms has huge potential to solve complex problem. Okay, I will discuss that now. For just to explain, as an example, if you see here on social sciences, now we have this social network, right? This social network that we have, Facebook, if you see, uses these features in their applications, for friend request and all. They've been using for other features as well. Okay, so nodes are, if you talk about these nodes, now these nodes are, for example, the users, and this ages represent basically the friendships. So the nodes that you see are users, and these ages are basically nothing but the friendship. If you talk about the social networking, okay, using graph based algorithm in very fundamental and layman terms, we'll build this from scratch. We'll use some of the Python library to use this. We'll talk about some of the fundamental thing like deep work, what are the P and Q values, how we decide those things. We'll go further in this tutorial. We'll talk about it. But just to understand, I was talking about finance, that why graph is extremely important in finance. One of the most potential use cases of graph based algorithms are anti-money laundering systems. When we build anti-money laundering tool, or system, basically that's called AML tool. AML has been, there have been some platform like Tiger Graph, for example, which is a very famous platform for graph based algorithms. They have very good documentation as well. You can use their platform. I will also cover that platform in the later part of this series, how we can use Tiger Graph to build an anti-money laundering tool, basically with help of Tiger Graph and Streamlit application. That will be Streamlit application. So you talk about money laundering, it's a very complex process. In general, money laundering is very complex, and they have a lot of hidden patterns. They have very complex relationship between one transaction to the other transaction. So there are multiple transactions. When you talk about money laundering, it's the money has been rerouted through different account, right, from one account in smaller chunks of the fund, and it's very difficult to look at all this transactional data. And then there are documents, financial documents. So you need this kind of graph based algorithms that can go through this knowledge bases, basically in general, to find out the hidden relationship and the complex relationship or the complex patterns. And that's where we'll see, we'll go further in this series, and we'll talk about it. Just to explain now graph theory, how do we define graph theory, for example. So if I talk about graph theory, it's basically, is it a mathematical structure, consisting of consists of set of objects. So it consists of set of objects that's called vertices or nodes, and set of connectors. So either it's set of it consists of set of objects and set of connectors. These are basically nothing but the edges, which link pairs of the vertices. Okay, basically the link pairing of the vertices. How do we define it mathematically, guys? Okay, how do you define a graph, for example? So I'm calling it G, and it will define as V and E. And here, if you talk about this is nothing but the vertices. We'll discuss this function in bit, and this is your graph. So these are your now, for example, if you have this nodes, we're talking about these nodes can be your it can be cities, depending on the data that we have. It can be city, it can be people, it can be cities, it can be people, that can be web pages. We have multiple web pages where we have knowledge bases. Nowadays, this graph based algorithms are twinned with or mixed with ChatGPT or generative AI models to derive more derive deep intelligence or better intelligence, right, in the chatbots. Okay, so cities, people, web pages, or molecules. Now if these are your nodes, what will be the ages, if you talk about it? So if it's cities, it can be your physical roads. We have roads in cities, right, that's connect to the cities across. And if you're talking about people, that can be your social relationship, that we were discussing the Facebook use case. And if it's web pages, that can be hyperlink. There are a lot of links available on web pages. So this is the fundamental thing, guys. Now we'll discuss about, there are different type of graph that we'll also discuss in uh, upcoming videos. Now if you see the first one, that if you talk about this uh, structure that looks like a graph structure, or looks like some kind of a network that I have created. Okay, now if you talk about this particular structure here in the screen, you don't see any kind of direction. Okay, so it's kind of an, you don't know whether it's a directed graph. So there are different types of graph. We have undirected graph, there are directed graphs. So we'll also cover that. Then we have weights given to those, basically the edges, there we can assign some weights. And then we also have connected graph. So we'll discuss all this in in today's video. We'll keep our focus on directed graph, and we'll also introduce a Python library called Network X, that how we'll use this library throughout this video series, of course with other platforms and libraries, for example Tiger Graph, as I mentioned. So today we'll see Network X, and we'll have a look at directed graph and how we can use the directed graph with Network X. This is what we are going to see. But if you talk about the properties of graph, as I was saying, right, so the basic properties of graph, the very basic, are either directed or undirected. Okay, so as I said, so the first graph that you see on top, it's an undirected graph. Okay, we'll see how we can use Network X to code a couple of lines and try to create some kind of graphs. So these are the basic properties of graph. So these are basic properties. It's the directed and undirected. So we look at directed and indirected. It's also called a digraph, by the way. Okay, so I'm calling it digraph. So each each of the edge that you will see, I will show you what I'm talking about. The edge will, that edges will have, or the edge will have, it will have some kind of orientation or direction. So it will have some kind of direction or orientation with it. Okay, that's called a digraph or directed graph. So orientation. Okay, now let's see how we can use this library, guys. I was talking about this library called Network X. You can see it over here. Okay, it's a very famous and extremely powerful library. We'll take some use cases. We'll take Twitter data, by the way, when you're working with some graph based algorithms later in this series. We'll see how we are going to use Network X to come up with this relationship on Twitter, right? So this is what we are going to do, guys. So this is the library. It says network analysis in Python. Okay, this is what you see it over here, by the way. Okay, so we are going to use this. It says it's a Python package for creation, manipulation, and study of the structure, dynamics, and functions of complex networks. And that's why we are using graph here, right? So, and this is how you install it. So this is, I will give the link in the description. It says Network X requires Python 3.8 plus, and we're going to use Anaconda. We're going to use Colab, but you can use Anaconda if you want, completely locally in your machine. It doesn't, for simpler task, it doesn't require any GPU as well. So what we are going to do, guys, today we are going to use this Colab notebook. I have renamed this notebook as Graph Introduction. We'll only have a look at directed graph. I want to keep this entire series with a smaller length video. I want to create 10 to 15 minutes videos for each of the video in this series. The next video will cover connected and weighted graph. Then we'll look at deep walk, and in the next video after that we'll create a movie recommender system. So we'll go one by one with the smaller set of video. I don't want to create lengthy videos in this series. So today let's look at directed graph. So let me just use, sorry, let me just use the markdown here. So I'm just calling it directed graph or undirected graph. Okay, undirected graph. So we are going to use this library. So it says pip install network X. We'll just copy this. You can also, if you want to install the complete version of this library, all the dependencies, you can also do all. You can see they have a very good documentation. If you go on top, you will see pip install network X default. So that will basically install all the with default thing that they have. But I only want the minimal stuff, that's why I'm installing pip install network X. You can also see it over here. It's limited subset of our functionality. So what I will do here, I'll just say pip install network X, and it will install it. Now just for your information, if you see, it says requirement already satisfied. So if you are using Google Colab, you do not have to install this library, it comes pre-installed. Okay, so Colab has multiple libraries installed for you already. For example, TensorFlow 2.x, PyTorch, they have Torch installed, they have all these things installed there, which are like scikit-learn, for example. Okay, and with others, so but if you are doing it in Anaconda, or you have a virtual environment in your local machine, if you are using it, you might have to install this using pip install network X by creating a requirement file or directly with this command pip install or conda install, the way you do. Now what we will do, let's import this. So what I'm going to do now, I'm going to say, okay, import network X as NX. You can see this is imported. Now let's first see that how we create some simple structure, the graph structure that I had shown you earlier on this screencast when I was showing. So I'm going to use the same kind of structure, and we'll create using this library. Let's call it like graph G, and I'm going to use this module called graph nx.graph module. I'm going to use this. Let's initiate this one. Okay, so I have used nx.graph module, and now what I will do, I will add edges into it. So what I'm going to do now, I'm going to do g dot, and you can see it's suggesting you. So it's suggesting you some of the method add underscore edge, then you have add edges from, and you have add node. All of this, like we're talking about weighted graphs, we're talking about connected graphs. We will all use this method when we are writing the code, for the particular use case that we will solve. Okay, so just for introduction, what we will do, let's call it add underscore edges. I'm just going to do from, and here what we have to do, we have to basically create this, or let me just do one thing. So inside this we'll now create our all the number of nodes or the number of edges you want to create. So let's do that. Let's see. So A, B, for example, then we'll have few more. B, D, B, E, and let's have the last here, let's call it something like C, G. Okay, and now this is the nodes and the edges. Okay, so you'll understand what I'm talking once we plot this. Okay, so now let's run this. Once I run this, you will see some kind of structure, okay, in this cell that we are running, the notebook. So let's run this and see. So once you run this, let's print G first. Okay, let's see what's there in G. So when you print, it says network x dot classes dot graph dot graph. So it contains the graph, but how will you plot this graph? Okay, so we have to plot the graph. We have to visualize this. So there are several ways. Either you go ahead and use the same network x default draw method. Of course, you can couple that with matplotlib, that we will do. And you can also use external visualization library that will use it later, like PyGraphViz, but not for this explaining simpler thing like directed or undirected graph. We'll use it when we are building, some application using Streamlit, or when we're explaining an algorithm. Okay, we'll use at that point of time, we'll use other libraries to visualize in a better format. So how will you visualize it for this particular thing that we have here, right? Directed or undirected graph. So for that we need matplotlib. So what I will do, I'll first have matplotlib is excuse me, sorry, matplotlib space inline. So I want to visualize this inside this cell only, this notebook. So matplotlib inline with this sorry so it's matplot inline, and the next I will import pyplot. So import matplotlib.pyplot as plt, and now so let's first run this. So you can see I have ran the cell. Now what I will do, I'll just use this method called draw. So I'm going to use nx.draw. It will suggest you, okay. If it's not suggesting, okay, in Colab you can see it says, if you hover over it, it says this function, which is a draw function. Okay, so I'm going to use this draw function. Okay, and in this draw you can see it's suggesting draw the graph G with matplotlib. So we have this graph G on top, in the top cell that we have defined it. You can read the documentation for this function, which say that draw the graph G with matplotlib. Draw the graph as a simple representation with no node labels or edge labels, and using the full matplotlib figure area. Okay, now if I just run this nx.draw, now let's run and see what we are getting, right? So I have to pass this called G, which is storing our graph, by the way. If I just run this, you will see some kind of graph. Okay, you see, you are seeing a graph, but it contains no labels. You don't know, okay, what labels have been assigned to these nodes that we have. You see all these nodes, these are basically nodes when I was explaining it earlier. Now if you go on top, you see we have these nodes A, B, A, C, B, D, B, E, and C, G in last, right? How would you understand? Okay, because it contains no labeling, right? So let's make that changes. What we have to do, we have to use a params called with parameters. So when I write, sorry, with labels, excuse me. So with labels, so what I will do, with underscore, and I will use this called with labels, in this nx.draw. So let's do that. So with labels, and I will pass this a boolean value which is true here. So I need this true. Okay, so I'm using with labels true, and then you can also save this. So suppose if you want to save this, you can also do that. So what I'm going to do, I'm going to do plt.savefig. Okay, I'm just doing savefig. Now once you run the this cell, you will see this all your nodes, you will be better able to interpret if those are having the same kind of relationship that you have defined. So you have A to B, so you see A to B, and then you have A to C, for example. Then you also have A to C, and then the other set of nodes and their relationship, right? You can also have a look at that. Now what I will do, I'll just make one changes, or let's do that. So what I'm going to do now, I'm just going to change this graph to digraph. Okay, the directed graph. Okay, so there is a module in network X which helps you kind of define a directed graph, and then you can have this relationship within that directed graph. So you only have to do one thing here. You just do call it digraph. Okay, so I'll just use digraph. Okay, this is the only thing that you have to change. Let's see if we are getting any different response when we make these changes. And now you see we have some kind of representation or orientation, the direction or orientation between the nodes, the way we have defined this. So if I go above, okay, you see AB. Now if you focus on this AB, we have this direction, the direction to A to B. We have a directed graph now. If you come down, you will see something called A to C. So all these nodes are now by linked, okay, with the link that we have, right? We were discussed about edges and vertices. So all these are now having linked pair. They have some kind of directions, with the help of this digraph module of network X. You see this. So the difference between directed graph and undirected graph would have been cleared for you now, okay, that how you have to define an undirected graph or how you have to define a directed graph. We'll use this technique. These are very fundamental things. There are a lot of applications when we are using this classical or traditional machine learning algorithm. For example, you have to cluster your algorithm. You don't know what kind of graph you need directed or undirected. We'll explore all this later in later part of this video series. So in this video, guys, what we did, we understood a little bit about the fundamentals and definitions of graph, how to define or the notation for graph. We discussed about the potential use cases. We also discussed directed graph and undirected graph. I will cut short this video now. Okay, I would like to keep it short. In the next video, we'll have a look at connected graph, giving some weightage, and we'll also look at something called deep work. Okay, we'll look at deep work. We'll look at node to vector, by the way. We'll look at all those things. We'll move slowly from from here to more of the data science thing, how we can take a problem and solve it. So that we will do in the next video, the next immediate video from this one in this video series. So that's all for today's video, guys. I will give this GitHub gist, maybe through a gist. I will give the link of this code snippet. If you require, you can test it out. I'll give the link of network X. You can install, you can go through their documentation. So that's all for today's video, guys. If you like the video, if you're liking the content that I'm creating, please hit a subscribe button if you haven't subscribed yet, and please do share this video with your friends and to peer. Thank you so much for watching this video, guys. See you in the next video.